Machine learning works by descending an error landscape called the loss surface. Imagine a mountain range. We start at the peak and want to reach the valley. But how big should each step be? Too big or too small both cause problems. This critical step size is called the learning rate. When the learning rate is too large, the algorithm takes enormous steps across the landscape. Each step overshoots far beyond the valley floor. It bounces wildly back and forth, gaining altitude instead of losing it. The loss oscillates upward dramatically. The model never converges toward the minimum, it diverges completely, spiraling toward infinity. Training fails. This is the critical danger of overly aggressive learning rates. When the learning rate is too small, the algorithm crawls forward with microscopic baby steps. Convergence happens painfully slowly. After thousands or even millions of iterations, only minimal progress toward the true minimum appears. Even worse, the algorithm might become trapped in a false valley, a local minimum, and never escape to discover better solutions. Computational resources are wasted needlessly. We waste time, electricity, and money. The perfect learning rate exists in a narrow Goldilocks zone, not too high, not too low. Large enough to converge quickly toward the minimum. Small enough to avoid catastrophic overshooting and divergence. Here, the loss decreases smoothly and steadily. Finding this zone requires systematic experimentation. Start with common values like 0.001 or 0.01, carefully observe your loss curve, and adjust accordingly. Modern optimizers like Atom help search this zone automatically.